Welcome to the Digital Forester Podcast, where we talk to foresters about how they are using digital technologies in their day-to-day forestry work. Hey, everybody. Welcome to the Digital Forester Podcast. Today, I'm joined by Dr. Elizabeth Hunter from Treeswift. She's the Chief Operating Officer, or COO, so it's a treat to have her join us. Elizabeth, how are you doing?
I'm doing great, Kevin. Thanks so much for having me on the podcast today.
Yeah, no, it's awesome to have you. I think both you and I are excited to have this conversation. We have some mutual acquaintances that have both been maybe guiding us or pushing us or maybe trying to force a collision path. So we finally got in to do this. And I know before talking, I understand you're expecting. So this is a crazy time in your world. So maybe this is like, I'm done this podcast and then, maternity leave's coming, but congratulations on that front. But thinking of that, I'm just curious to know how you got into the space, your journey, because I believe you're based out of Philly or in that area, University of Pennsylvania, mechanical engineering background, some work with spine robotic work, and now you're with Treeswift. So maybe for our listeners and viewers, tell us your journey on how you came to be where you are at Treeswift.
Yeah, of course. Yeah, so like you said, I'm based in Philadelphia. Actually, how I found my way here physically to this location is I came here for school. So I studied mechanical engineering and robotics at University of Pennsylvania, or Penn. And my background is really as a technologist and as a robotics engineer. So I'm not a forester by training. And in fact, I think forestry really kind of found me. It was like a series of really serendipitous events that kind of led me to meeting my co-founder for Treeswift and kind of founding the company together a few years ago. But how I got there is originally I was really involved with robotics research. So after completing my undergraduate in mechanical engineering, I pursued my PhD at Penn in robotics. And so my work was really focused on autonomous systems and robot teams, but at very small scales. So I was actually working in the lab, toiling away late into the night, kind of day after day, working on very small scale robotics. So think about a robot the size of a caterpillar. Or even smaller, so insect scale or even cell sized robots. And so I was developing new sensing methods, so how we can actually take measurements from the environment using these small robots, how we can get them to move or their actuation, and how we can actually control them, so getting them to go from point A to point B. And this type of robotics has a lot of um, biological applications. So I actually worked on this really cool collaboration with Penn Dental Medicine, where we were using these robots to actually clean biofilms off of teeth, and using them to sense various like environmental signals. And so, all while I was doing this, my co founder, Stephen, was working on robotics for a different application, still kind of in nature or natural systems, but he was working on drones, looking at counting fruit in orchards, so actually estimating fruit yields. And we had always kind of talked about kind of how robotics, we had always kind of talked about really kind of getting the technology out of the lab and like really seeing the impact kind of in the real world. And at the time I was actually on the tenure track faculty routes. I was interviewing actively for faculty positions, just envisioning what my lab would do, and had this whole path. And Stephen asked me to co-found the company with him, and then that kind of took it from there. And there's kind of this leap in going from the robotics, the small scale robotics, and the robotics for the apple orchards. We actually had an opportunity, kind of while we were still students at Penn, to actually go down and put some of our robots in southern pine forests, and kind of take a look at what they could do down there, and kind of kind of the company took off took off from there.
Wow, very, very cool. So amazing with like I'm gonna call it the little robots because that's probably as sophisticated as this guy's gonna get with them. But I'm curious, did that interest stem from something when you're younger, like you had the remote control and you had these robots that are fighting? I think there's a TV show where you build your robot and they're like trying to kill each other in a cage or something. But where did this interest in the tech side or the engineering, the robotic side come from?
Yeah, so I had always kind of been interested. So I kind of growing up, so my dad, I call him, a self-taught engineer. Like I grew up, he's an entrepreneur, and I kind of grew up kind of watching him kind of fix various like machinery and other things, and was just kind of really fascinated by like mechanical systems and just like the way that they worked. And then kind of as I kind of got grew up and kind of went to school and kind of learned about the spaces, the little robots or these kind of small scale critters, was just really fascinated at how like man-made systems can really interface with natural systems. So how we can use really engineered systems to study these natural systems, to interface with them, to help diagnose kind of various diseases or kind of pathogens in the environment. And I was that kind of interplay between kind of the organic systems, kind of this nature, and kind of what we can really kind of engineer and build. I was just always fascinated by it. And so now it started off in kind of that little robots realm. And now we're doing something similar, but very, very different in terms of the scale of the robots at Treeswift.
Yeah, for sure, and we'll dive into that shortly. So I assume out there is probably the world's proudest dad, daughter with a PhD, entrepreneur, startup, just killing it. So that's amazing. So in my household, I've got a 12. I'm looking up to the sky. Normally, moms know this information better than dad, so I got to try and get it right. I got a 12-year-old, yes, a 10-year-old, and a 5-year-old. But the older two, they've discovered the Marvel world. So we just finished Iron Man and think Thor, and whenever there's like people kissing, they're like covering their eyes. But I'm curious, like as a PhD in robotics, is your house like Tony Stark's house where Jarvis says like, "Hello, Elizabeth, welcome home," and doing all this stuff, or is your home kind of like every normal person? So I'm just curious, given that, like, is there, some you come home, there's a glass of wine that comes on the robot with the happy face there. Share what that how robotics has permeated your everyday life at home, if it has.
I think that's something I wish, it was funny, or kind of now that I'm kind of preparing for maternity leave. Our business development manager was joking with me the other day, and she's like, "Oh, Elizabeth, in all your spare time, you should have created a machine learning model of yourself while you're on leave." But yeah, didn't quite get around to working on that in all of my spare time. But what's really funny is, my house was once kind of taken over by some robots. I actually finished my PhD at the very start of the pandemic. And so I remember kind of as everyone kind of experienced this, mass evacuation from their workplace or other things, I had like two experiments that I had to, finish up before defending my thesis. And so I think that, the very uh the basement laboratory that everyone like thinks about when they think about, a scientist kind of toiling away. I actually had to recreate some of the robotics setup in my basement actually,
What?
about two months before defending. So I remember kind of going to the lab and kind of grabbing some of the equipment, and I was working on magnetic uh, magnetic actuation of these like very small robots. So it was all these magnetic coils and other things, and I was able to finish the control experiments. So at one time, I did have a basement laboratory in my house.
I knew it. I knew you had a Tony Stark basement all set up. There you go. That's amazing. I'm sure your partner loved that, having the man cave commandeered by research, all in the name of science, right? So super cool there. So I'm also curious. You mentioned your co-founder, just out of interest, again. Having gone through that journey, I'm sure entrepreneurship from 0 to 1 has gone in a perfectly straight line. Everything's gone according to plan for our viewers, where Elizabeth and I are chuckling here on that front. But did you know your co-founder before? I know you mentioned you were talking, but was that just through grad school, or was there an earlier connection? And depending on that answer, um, how did you overcome like getting started? Because you're still a student, right? So you're trying to balance trying to finish the PhD. And I'm sure somebody was like, Elizabeth, you have to finish this thing. You can't, like a lot of people, just go up in the startup mode and forget about grad school. But maybe tell us about the early formation of Treeswift. Like, what was the magic sauce or the secret ingredient that kind of lit that spark for both of you?
Yeah, no, that's it's beginnings are really special in kind of beginnings of companies. And I think there was definitely the ingredients of the right team and the right time. So my co-founder Steven, so there's actually four co-founders. So my co-founder Steven, he's Treeswift CEO. I met him in early 2015. And so he was actually working with me on some projects actually related to these little robots. And we wrote some papers together and kind of collaborated on work. We went to conferences together. And so, we were always friends in the lab and kind of collaborators, and we're always kind of working on various ideas and talking about, I think the one common thread there was like talking about how we actually got this technology that we were working on out kind of into the world, and really being used. We see robotics really being pervasive in so many different industries now, from construction to mining to logistics to healthcare, that really, I think that, we're at this really special time where we're seeing a lot of the commercialization of robotics work. And so, he and I kind of were talking kind of more towards the end of my PhD, about starting a company together. And then we also brought on two other co-founders, really fantastic individuals, that are also have a pen connection, from robotics as well. So we started off as a team of four robotics engineers, kind of with various backgrounds. So I've talked about my background, but Steven's background is really in autonomous systems too, and aerial robots and controls. And then our CTO has a fantastic background with self-driving cars. So he actually worked on self-driving cars before coming to TreeSwift. And really kind of that kind of like DNA kind of shaped the team. And now today, we're a team of almost 40 people. And it's not only roboticists anymore, but it's we have an incredible director of GIS. We have foresters on staff, really fantastic operations people. So it's really just this awesome mix, of folks that we've built since then.
Yeah, that's amazing. So from 4 to 40, and I believe you guys did a seed round raise, so went through all that process, as I'll call it, which is a different exercise. But so thinking of that, like, why don't we jump in maybe that bridge between forestry? You touched on it, that a bit of ag tech, and then now you're in the forestry side. So maybe introduce us, or I'll say me, to what Treeswift does, and what problem are we trying to solve, and what's the cool tech, and then we'll kind of poke at little pieces to the extent of what you can share. Since I'm sure by now a lot of people have perked up in their chairs and said, "I really need to learn about the big robots now," and although still curious about the little robots. But tell me that connection. What was that moment of saying, you know what, we're going to leave the fruit side of ag, or maybe the viticulture side, and go full bore into forestry? Maybe there was a nudge, but share with us what that spark was to go into forestry.
Yeah, so there was a bit of a nudge. So kind of through again a serendipitous connection, kind of a friend of a friend, actually through Steven's network, we met really an incredible individual who really works for a large landowner and manager in the South, and so he kind of saw some of our videos of drones flying in orchards and was like, "Hey, have you guys ever tried this in a pine plantation?" And the answer to that was no. And so we at that time we kind of went down and took some of our robots kind of into the forest and just kind of were looking at, what could we really do here? And we had the opportunity to really meet operational foresters, managers, speak with them about kind of their pain points and problems they were encountering. And what that really led us to was robotic timber cruising. So right now, what Treeswift does is we've scaled our technology and our solution. We're actively providing timber cruising services and carbon cruising services across the Southeast and Pacific Northwest of the United States. And so what we really kind of built, or what that nudge kind of from really a friend of a friend enabled us to do, was build out a specific sensor that is specifically designed to measure trees. And really kind of our kind of edge in our technology is that we're focused all underneath the canopy. So with our timber cruising solution, oftentimes when people think about our sensors, which are composed of LiDAR and cameras and kind of many other sensors combined, um, you know, people kind of are very used to the view of measuring a forest from over the canopy, but we kind of think about the gap between what's underneath and kind of what's over top. And robotics is really a unique solution, kind of the problem of kind of getting the sensors underneath the canopy. That's a problem uniquely suited to robotics in our view. And so we started developing these sensors to measure trees. And so now we're deploying those sensors at scale and really cruising thousands, tens of thousands of acres of timber in the Southeast and Northwest.
Very cool, very cool. So if I heard you correctly, the IP or the innovation is in the hardware in terms of how you're stitching some of these things together, and then the AI, I guess, machine learning or deep learning, and you're out there cruising. So super cool. Are these aerial drones this gets put on, or are we talking a Boston Dynamic dog that can dance and flex its legs, or what type of drone platforms are you mostly using these days?
Yeah, so we actually designed our sensors to be platform agnostic. So we started off really putting them onto an airframe. So I think that's actually been one of the really interesting things about our technology and our approach to development, is that all of our hardware and also all of our software stack has been developed at Treeswift. And so the hardware specifically has been made for forestry to operate underneath the canopy. So when we started off and mounted our sensors to airframes, to drones, those were drones that were designed in-house by our engineering team, and specifically were designed to fly underneath the canopy. And then since then, we've actually now developed a new system where the sensors are mounted on a backpack-based system. And this is something we're really excited about because with the drones are awesome in the sense that there are very kind of specific use cases where the drone using the drone really shines, like certain forest types, and it's very efficient to use the drone to collect the data needed to produce a timber cruise report. But the backpack has really been an interesting innovation for us. It's the same sensor that we've put on the drone, but now in a backpack system, and anyone can use this. And so we've really found the backpack to be a very scalable solution. So we've heard a lot from our customers, specifically that it's pretty challenging to find timber cruisers these days and people to cruise
Sure.
timber. And so one of the things that we really are excited about, and one of the missions of our company, is to really increase access on who can cruise, to really approach and solve some of these labor force problems as we scale. And so this backpack system has our sensor. It can be walked through the woods in order to collect all of the measurements that you would receive in a timber cruise report. So diameter at breast height, total height, height to live crown, really rich semantic information about the stem. So the basically any defects, so if the tree forks, if there's a crook, if there's a sweep, and the height at which those defects occur. And we can also map very precisely where the geospatial location of each stem is.
Very
And so this
cool.
kind of goes into the software piece too.
Very cool. So when you say you can map the position, is this like super duper high precision, like tens of centimeters, or that's what you're thinking? Yeah. So very cool. So I think of back in my days where I had to carry this, this LiDAR portable backpack, and in principle is great, but the thing weighed like 90 pounds. So is this like the good life or whatever gym Gold's Gym workout with your backpack, or is it something a little bit more reasonable for those that are more bound to an office chair these days?
What's really, I think this is a great question, Kevin, because a lot of people ask this is, how much does this backpack weigh? Are you carrying like a bowling ball back there? Is it, and so one of the really great things is because the sensor was originally designed to be flown on an airframe, it had to be very light. And so, the drone, like the Treeswift drone, is actually it's a very small airframe. So it's a lot smaller than many kind of commercial off-the-shelf drones that have been traditionally used in agriculture, or even, some forestry applications too. And so it purposely had to be designed to be light, so it's only a couple of pounds that's
Oh,
added to
wow.
kind of a backpack frame. So it's actually really light.
Yeah.
And I think that that's really important as we think about, still kind of going out and doing field work and being on plot. It's actually something very kind of specifically we've designed into the cruiser user experience.
Yeah, for sure. Very cool. So glad to hear I don't need to start a 26-week boot camp to use this backpack, although I probably should do the boot camp irrespective of that. But thinking of other things, just channeling the listeners, the viewers, how long can this thing run? So I guess what's on the UAV, there's a power component. You've mentioned that you've custom built the airframe, or essentially the drone. So is this something that lasts like hours, or are we still kind of in that traditional wheelhouse of 45-minute flight, and then we've got a ET phone home, get a new battery pack, and go again? Can you share more about the specs, I guess, of how one might actually use this?
Yeah, certainly. So Kind of how we're cruising today in this, I guess, like the specifications are really kind of informed into how we're cruising. So currently, all of our cruises, rely on a sampling plan. So similar to how traditional cruising is done, our force inventory manager lays out a plot grid and we sample at various points. There are a variety of reasons why we took that approach, but really kind of one of the um, one of the really kind of fundamental key things in our development has been really giving our industry a solution that um, fits within systems today, which is increasing adoption and making it easier to use. And so when we think about plot layouts for the drone, if we're sampling with the drone, we're able to kind of capture multiple plots, 4 to 5 different plots within a 10-minute period of time. And our operators kind of go out with enough batteries to last, the day, kind of a day of work. But what is really great about our backpack solution also is again, because kind of all of the power specifications and everything were kind of initially designed to be on a drone, the backpack, can be run kind of for a full day of work, and then at night kind of changing things out and resetting for the next day.
Very cool, very cool. And so thinking of doing this work, is this at edge processing, like you're collecting remotely sensed data? Is it being processed at edge, or is it more of a data collect, bring it home, and then some magic automatically spits out what you actually need? What can you share on that front of the workflow? I'm really trying to figure out. I went camping once, and then my backpack was always the heaviest, and I realized that everyone was putting the cartons of wine into my backpack, and I didn't realize this till like the 5th day. So that's why I'm kind of asking these questions of, are there hidden backpacks I gotta carry, even though this thing is only a few pounds? And like, if I gotta bring data drives, and suddenly I'm back to,
Mhm.
I got to do the 26-week boot camp before I get to use this thing. But can you explain, or maybe share in terms of that pipeline? How do we actually get to the final cruise outputs?
Yeah, of course. So really just an overview of our process is, if we're going to go out, do a cruise, and we're actively cruising projects that might be 10,000, 15,000 kind of acres at a time, so thousands of plots kind of within a project. And so how we think about it is we go out, so Treeswift operators currently go out, they perform these cruises, so the data collection and the field work, and then we take that and we process it through our Treeswift software stack. So all of the really rich LiDAR data, the camera data, so we don't just use LiDAR. This is actually something that we've found kind of within our work and kind of our analytics, is that LiDAR is not necessarily enough to kind of get the full spectrum of what is required in a really robust tree list and inventory. So we take many different pieces of our sensor information and then we push that through our Treeswift software stack. And so that includes the LiDAR processing, it includes many things about associating sensor data to that point cloud. We can track individual trees kind of through our processing and be able to, one of the things that we're really able to do that's really special is, if a tree has a particular defect and maybe the DBH needs to be measured at a different location on a tree because of a butt swell or something like that, we're able to know exactly why that DBH measurement was kind of taken at a different location because of that per tree defect. And so kind of going back to this process, we have a various like data offload process, and we have cloud processing, and we utilize many different things, but it all kind of this all is within the Treeswift software stack that we've developed.
Very cool, very cool. So I'm also assuming with all the, I call it the auto magic, that's That's what my life has been reduced to, the magical things that happen behind the scene. But I'm assuming that this pipeline's pretty fast. Like if someone goes out, collects the data, we're not talking days or weeks for this auto magic to happen, probably hours.
The processing time, it varies kind of per project and kind of how much is being collected. Kind of our goal is to always kind of get that decrease that as much as possible. But right now it's kind of on par with typical kind of cruising data turnaround times. And yeah, as our algorithms kind of develop, that processing, gets better and better.
For sure, for sure. Very cool, very cool. So thinking of the tech stack before we kind of poke in it, because I'm curious as a tech person to learn more, but I'm curious about how the forest industry or community or ecosystem, whatever word we want to use, how they've received it. Like you mentioned, you're working in the US South and then the Pacific Northwest. Uh, are there some funny stories or crazy stories? Because you're coming from robotics, you understand that very well. I've got a problem. I'm applying technology. We're pulling this data, these metrics out of this data set I've collected. But has it been a straight path? Have foresters jumped on board immediately, or have you gotten a bit of the what are you going to replace my job, or there's no need for boots on the ground? Share some of your experiences if you can in terms of that journey to get to that point where, yeah, we're actually doing trials, we've got customers who are paying, they're bought in. I'm assuming there's probably maybe been a little bit of head scratching, maybe resistance, I don't know.
Well, I think one of the things that's really interesting about forestry is, this is, you know, Treeswift is not the first company to kind of come and think about using drones in forestry, and to kind of communicate that value to customers, and that's something we recognize. And I think one of the things that kind of we've found is that kind of a lot of these technologies that are sometimes brought into forestry come from agriculture. And it's not really a one-to-one correlation at all between what works in agriculture and what works in forestry. And so I think the unique thing about Treeswift is that we're all in on forestry, and we have been from the very beginning. And so what that has allowed us to do is really work with our early adopters and our early set of customers, and not only give them a front row seat, but actually really empower them to, they are, the hero along this technological journey, really driving kind of what we build at TreeSwift. And so I think that's been really our approach to innovation as a company, is that we're customer first, and especially with our early adopters, listening to them, understanding some skepticism, which is completely understandable, especially when we're kind of, going into the woods together and, describing, hey, you can replace a D tape and a clinometer with the TreeSwift sensor package, and it's just as good and it's just as accurate. But hey, you can get so much more rich information from this sensor, that you can now kind of um, reimagine what's even possible in forestry. And so I think that certainly, I think this happens a lot with new technologies, kind of regardless of the industry, is that of course it's met with some skepticism, but really the job of the entrepreneur, the job of the technologist, is to really listen to the customer, understand where they're coming from, and make sure that these solutions are designed to be really accessible, kind of actionable as soon as possible, and transparent. I think that's one of the things that we've focused on a lot as a company, is working with our customers so that they understand our processes, our approach, And so we've actually one of the things we've developed is a really robust auditing process of our technology. So anyone can audit our data. You don't have to have like a specific Treeswift widget to do it. And that has actually been pretty powerful that you can audit our data just like a traditional cruise as well.
Very cool, very cool. So that transparency aspect you're bringing in and ensuring people can see and touch and play. You touched on accuracy and precision, so I suspect there's probably some folks who might be listening, viewing, wondering what does that mean when you say that? Is this we're kind of hinting, I guess, together that in our conversation that we can do it equally good, if not better, than the traditional method. So obviously there's going to be people out there going like, yeah, but what does that mean, Elizabeth? So I'm assuming, again, with your early adopters, you've done some validation and tests. And what's that what's that thing you would share in terms of appeasing or squashing, or maybe putting that question of like accuracy and precision to rest? How good is it?
Yeah, so this is and forgive me that they're not in metric units, Kevin, but we have done validation studies. We've done audits of hundreds of trees, kind of really looking at our projects, especially in the Southeast. There's some type of audit that happens regardless, kind of on anything that we cruise. We do internal audits and kind of internal studies all the time. And so still when we're thinking about about treeless, really DBH and height are the core kind of metrics, fundamental baseline. If you don't have that foundation kind of in your inventory, kind of then everything else, it's great, but everything really relies on that DBH and that height. And so we've really focused on not only collecting the data, but really the data and the metric side has always come first for us, making sure that our software stack is really robust and designed to produce the best quality data possible. And so kind of in our studies, what we found is that we're within zero 0.1 inches kind of margin of difference with traditional measurements and within 1 to 3 feet on height generally. So we really kind of like to think about this as a difference because kind of when you're within that range, who's to say that the clinometer, the tape is kind of more accurate than the Treeswift sensor. So we kind of think about it as differences that way.
Yeah, for sure. That's a great point, and an objective measurement versus a human one, which depending on how many Bud Lights might have been had the night before, could completely influence the measurement. So very cool. One thing I wanted to get your input on before we kind of shift maybe more broader, because it sounds super cool in terms of technology, but from the business model point of view, are you thinking you're providing the cruising service to forestry companies, or eventually are you thinking we're just going to sell the technology and we've got this platform to ingest and then spit this out as a service to you? What can you share on that front for folks that might be kind of scratching their head going like, is this something I buy or is this something I hire?
Yeah, no, that's great. So today how we operate is we operate as a traditional kind of cruising contractor. So if a customer wants to perform a carbon cruise, a timber cruise, kind of our process works pretty much the same way. So our Treeswift team goes out with our backpacks or our drones and performs the cruise. We collect the data, we push that through our software stack, and then at the end, our customers receive a database cruise report that fits within their systems. Um, I think what's really exciting for us as we think about kind of the future and kind of how our business may evolve is we really think about this being our under canopy data really being a layer in the stack of kind of all of the other data that exists. So aerial LiDAR, satellite. We really like to call this kind of the last mile problem for forestry. So in logistics, when a package comes to your house, there are these kind of last mile warehouses located around where that package may have gone on a plane, on a truck, kind of to get multiple trucks to kind of get to close to its final destination. And then the last mile problem is then actually how does that package get to your house. And so when we think about all of the layers of data across the landscape, from satellite to aerial LiDAR, aerial photogrammetry, and we think about kind of penetrating that canopy layer and looking at underneath the canopy, that's something that we're really excited about, that I think our technology is really uniquely suited to kind of provide. And so we really think about kind of all of these data layers being connected. And then ultimately, another thing that we think about as our business evolves kind of beyond what we're doing now is, again, kind of empowering foresters to use our hardware. And so using our hardware as, another tool in their toolkit, that really makes timber cruising more accessible, cheaper, it's more efficient. And so really kind of getting our hardware kind of out there at scale for other people to kind of be using and collecting the data, while we really kind of continue on that data software stack at Treeswift.
Yeah, for sure. Well, the beauty of it is, as some folks who might be listening with that entrepreneur background, it's sometimes, as you said, listening to the customer, what they need, and pivoting and course correcting accordingly. So very cool. I'm curious if we shift gears a little bit and say, from a technology point of view, I'm dying to know what gets you up tomorrow. Like, again, you're coming from hardcore robotics. As we joke about the little robotics, you probably could have gone health road and tried to cure cancer with little robots at that nanoscale. But from a technology point of view, what if you look out that 1 year, maybe 3 year horizon to start off, are there things that you're watching? And I know you're not the CTO, so the CTO might be listening going, hey, that's a question for me. But again, all of you, you're small, you're tight in a line. But what's out there now that you're kind of like, it's like, this is something I'm keeping an eye on, and Forrester should keep an eye on as well?
Yeah, I think we're really living in just an incredibly exciting time. And I think one of the things, I mean, this has been, kind of these various kind of like buzzwords or things kind of people talk about, is really kind of data has infiltrated kind of so much of what we experience, kind of what we see, kind of when we think about just like interacting with various platforms. I mean, how much kind of data inputs various companies receive from kind of our cell phones and just kind of interactions every day. What makes me excited about data, kind of apart from like what has been traditionally talked about, is, and this is more so again like in nature and kind of in forests, is just this idea of connected connected forestry, a connected landscape. One of the things that is really exciting is thinking about other kind of sensing mechanisms in kind of in nature beyond physical sensors or geometric sensors. So like LiDAR and images and so like some of these other sensors, they're very much like physical kind of geometric. They capture geometric information. And I think what's really interesting is kind of layering on other types of sensing that provide different inputs. So whether it's a signal from southern pine beetle or mountain pine beetle, and that would lead to kind of earlier diagnosis of maybe an infestation, and how all of these kind of data sets can work together in order to kind of protect, preserve forests, or also inform better forest management. And I think as we're seeing a lot of trends towards carbon and the carbon market, there's really kind of been some nudges for kind of more robust data sets, and kind of looking at measuring forests in different ways, which really I'm really excited about.
Yeah, very neat. And so you mentioned carbon and timber cruising. Is there one side of that equation? Well, I guess it's not really an equation, but is there one demand side that you're sensing is pulling you more? Because again, with the carbon world, it's crazy, and as someone who's raised, that climate tech space is crazy as well. Are you seeing any patterns there that you think you might get pulled one way sooner than the other way?
Yeah, so I think that kind of when we think about our measurements and the measurements that we provide, one of the things that's really exciting for us is that you can actually perform a timber cruise and a carbon cruise in parallel. So with our data sets, there's really nothing preventing us from performing a carbon cruise if one of our customers, orders a timber cruise. We can still work up the carbon data from that without having to go back a second time and doing like a whole other cruise. So I think it's more so kind of thinking about really the value of this data to the landowner and how they want to use it to make informed decisions about kind of their forests and the property that they manage. I think that's the way we think about it, is just kind of equipping them with kind of more information and more tools, and so that they can make the decisions kind of for their business that they think is best. I think one of the really exciting things about our data in carbon, as I mentioned, that we geospatially locate all of the stems of the trees. And this is to a very accurate map. So like the relative accuracy of our maps and our forestry constructions are centimeter level precision. Now the absolute accuracy of that kind of with kind of put back into like a global frame, that's a bit different, but the relative accuracy, just tree to tree, is centimeter level precision. And we're able to track again all of the metrics back to that individual stem. So it really provides a virtual way of being able to see, to interact with the forest, that kind of a straight treeless database doesn't necessarily provide the window into it. And so I think that there's certainly use cases where that's valuable in timber, but then in carbon, of course, just with the compliance and just the various degrees, of the protocols and the methods, it has to be even more kind of transparent and monumented of what gets measured in those cruises.
Yeah, for sure. And I'm curious to know, I was curious to see if the word digital twin would pop up. And I'm wondering, are you intentionally avoiding that term? Because we're kind of you're talking about that. I'm basically reconstructing this digital twin of this plot. It's a virtual plot. So I'm curious, are we avoiding that intentionally because it's a buzzword, or are there other reasons in your seat that maybe it means something differently to you?
No, I don't think I'm intentionally avoiding it, or I think one of the things that's interesting about it is yeah, when you think about like our data or virtual reconstructions, it is a digital twin of the forest. But I think that there's kind of there's kind of so much, there's more kind of to it when we think about the data that we're producing. So it's not simply a kind of one-to-one twin map a LiDAR point cloud, but we have images of every tree and images at various angles of the tree. And we can kind of put all of this into this, a viewable format for foresters to kind of look at this from their desk. So no, I mean, it is a digital twin. I think there's just kind of a few more layers kind of in there as well.
For sure, for sure. So I'm going to kind of bring us full circle, and I'm loving this conversation. I think we could spend hours talking, but we're not going to pull a Tim Ferriss podcast and create a 3 hour and 45 minute podcast where you got to break it into chunks. But thinking of your journey, I'm curious, and we touched on just in general workforce and finding talented people to cruise. But I'm kind of curious to pivot maybe away from that and just get your thoughts on your journey as a woman in forestry, a woman in technology, a woman in entrepreneur. Has that journey yielded any interesting insights into barriers for women getting into technology? Again, with three girls myself, we often hear, well, actually, that's not necessarily true. I know at the university level, I think there may be more women in engineering now than men per se, but I'm just curious on your side, because forestry itself traditionally, boys club type of thing, and you and your team, you're bringing technology. But what does that journey mean like from your seat as a woman innovator in technology in general?
Yeah, no, that's great. It's also just great to hear about kind of your family, and I think kind of all along my journey, I've always kind of I've been involved with kind of various women's groups in robotics and engineering. Now in forestry, I love when I'm at a forestry conference and there is a a working session or a social hour that is, women in timber, or a luncheon. I think one of the things that those events and groups do, I know the Women's Forest Congress is going on right now. I think it's an incredible inaugural event. But one of the things that this does inherently by kind of having these events and platforms for women in technology, women in forestry, is just kind of increasing the visibility of women. So there are women all across in forestry and engineering, and I think one of the best things that kind of we can do in our industry is really elevate and amplify those women's voices. So it's really that women are seen kind of doing these jobs all across of forest operations, management, from the technology side, cruising. I mean, there are women doing these jobs, and I think one of the best things that we can do is just kind of amplify and echo that. And I think that I see kind of more platforms and various programs kind of coming out that do exactly that. I'll give a shout out to Daniel Atkins' Land and Ladies program, which is an incredible kind of woman landowner education program. And so there's just kind of more and more of these programs coming out. And one of the things that I love doing is like when we have on-sites with customers and kind of go in and teach them about our technology. I love teaching kind of other women foresters and folks at our customers organization just about our technology too. I think it's great to build those connections as well.
For sure, 100%. Last question from my side is maybe less about forestry, but about innovation in general. You're not in Silicon Valley, you're up in the Philadelphia area. What's that ecosystem like? Again, it's probably more of a Kevin Lim self-serving question, just learning more about that ecosystem. But what can you share in terms of what that community is like in your region?
Yeah, so Philly and generally the Northeast, it's a really great kind of kind of springboard and like nurturing community to early stage technology companies. So Treeswift is actually our headquarters. We have a large office kind of in a building kind of with other robotics and early stage companies. I think one of the things that has been really great too about starting a company right before the pandemic is that we've inherently kind of grown as a remote company. And so we have folks working everywhere from Silicon Valley to Huntsville, Alabama to North Carolina, Georgia, Philly. So we've really kind of expanded kind of our geographic footprint in that way, with a lot of our engineering kind of still happening in Philadelphia and kind of the core engineering team here. But it's a really rich community, kind of just with innovation and vibrancy. I think we see kind of a lot of these cities across the nation really kind of supporting early stage technology companies in a variety of ways, and whether that's kind of incubators or kind of maker spaces and other things. It's been really great to kind of have our initial start in a place like Philly.
Yeah, very cool, very cool. And I suspect you probably represent today's modern startup where, there's an HQ, but the workforce is distributed, just as you said, as a nature of thank you, COVID, for that part, I suppose. So as we wind down, as I said, we can go on forever. There's like probably 50 million questions in my head that I want to ask, but as I said, we're not pulling a Tim Ferriss podcast. Before we close out, I'm curious, if we look out 10 years, what are you excited about? Are we into that Elon Musk world of the neuro, whatever thingamabob that's plugging into our brains? 10 years out, what does that world look like from your seat?
Yeah, so I think that there's again, like, this couldn't be a more exciting time. I'm going to kind of circle back to maybe the beginning of our conversation, which is really where I think kind of technology, the interplay between technology and nature, kind of this has been a theme that I've been really excited about for some time. And if we think about there's this concept of the bioeconomy, and it's basically how really biology can be used as building blocks for kind of various man-made systems. This is nothing new in forestry because that has been happening using trees for construction materials has been happening for some time. But kind of what I'm talking about here is more so just really using technology and developing kind of biological systems to kind of more so integrate kind of with our everyday life, whether that be textiles, kind of various like bioelectronics, other things, and then kind of the other side of that coin is then how can we actually then use man-made systems, mechanical systems like new sensors and robots to kind of study biological systems in new ways, and kind of what can we learn about them. So I think that this whole era of the bioeconomy and kind of using technology, driving that forward, and kind of nature-based kind of solutions that might be engineered a bit is something I'm really excited about.
Yeah, amazing. That's awesome to hear. I'm chuckling inside because classic entrepreneur, just the art of the possible. There's all these other things, Elizabeth is already thinking about wanting to solve beyond just the tree swift mission that you're on. So I really appreciate the time. Love this conversation. Thinking for our viewers and listeners, what's the best way that they can get a hold of you? Is it email, social, website? Give a shout out for Treeswift. How do they get in touch with you?
Yeah, definitely. Visit our website at treeswift.com. Also, our LinkedIn. LinkedIn is a great social to get in touch with us, and I can always be reached at hello@treeswift.com.
There you go. So three ways to get there, and Treeswift's one word if you're doing the good old LinkedIn, but hopefully you know how to use the Google everyone by now. So hey, thanks so much for joining. I had learned so much, to be honest with you. My brain is now firing. Definitely appreciate you carving out some time, and I know you're not too far off between before maternity kicks off. So gonna wish you all the best of luck in that new adventure. And I look forward to meeting you in person one day and exchanging more fun conversations.
Awesome. Thanks, Kevin. It's been a pleasure.
Awesome. Good stuff. Bye for now.